Because Andrew, when I ordered this one, they accidentally did a whole bag.
All right, so all right. So what we're gonna do is we're gonna talk about average rate of change. We already talked about that, so don't get confused between average rate of change. So I'm gonna write it down so that way you don't get confused. Rate of change. And I know all you guys gonna get confused, so come up with a way that you don't get confused. F of B minus F of A over B minus A. Now, this one is a slope, right? Slope usually represents a derivative.
Click on the tab below it.
Oh, my bad. So let me do this.
This says it was $80, but I don't think I paid $80.
Some of the feeders.
Oh, was it $80?
Bruh, that's stupid. Why would you pay for that, you bozo?
I don't remember paying $80. If I did,
Yeah, just pay for all like
$80. You got ripped off. I'm sorry.
Hold on a second.
If you pay $80,
no, alright, it was $49. No, it was 40.
Oh my.
40.
Is it a one-time payment?
You can raise. You can give me two years
You
raise.
got ripped off. You could just ask Mr. Ye to show you the stats. He'll just teach it to you.
No, alright,
Absolute bozo.
let me tell you, it has step-by-step work and no ads.
Yo, that's step-by-step work and no ads. It's tutoring. You just go to tutoring.
I don't have time. I actually have a life outside of school, unlike you.
But like if you
Okay,
just
AJ,
make it,
AJ,
if you're just doing the homework, he does that in tutoring and then he ups
AJ, what is that extra? Like, what is that extra like 10 minutes buy you? Like,
Alright.
I just stay up.
By the way, do you see my new flag?
MIT.
Who went to MIT?
Who is
You know what?
10?
I'm already committed there.
Huh?
I'm already committed to MIT.
You already come in MIT.
Yeah.
Who is
They
doing-
sent me my care package.
Who's saying? Who are these?
You're being rejected. No, I'm just kidding.
No, I literally applied to Harvard so I could frame the rejection letter.
I want to do that too.
Who is sighing?
When I was in high school, I was like, I just want to get a rejection
Yeah, that's what
letter.
I'm saying. It's a $30 rejection letter, but
Calvin.
I mean, give me a question, like,
I will get paid to reject it by Harvard.
that's wrong. It's a mindset.
I'm literally in the school of Alabama already got rejected by Harvard this year, so.
All right, so average rate of change, it's gonna be F of B minus F of A over B minus A, and so on that same token, I'm gonna review a little bit about instantaneous. You guys remember what's instantaneous, right?
It's like one. It's like instant.
It's a f prime of c. Good. So f prime derivative at single point. So that's a slope. That's like a speed of a car. It's like a laser gun shooting at your car, and to see how fast you're going. So that's that. Now there is something called average value. So this is something that we learned before, but this is the average rate of change, instantaneous rate of change is something we learned before. And reason why I want to talk about this is because sometimes people get confused between average value. So average value is a new thing, okay? It's a new thing. So integrations of f of x dx. So unlike average rate of change, and that's what people are going to get confused about, please don't get confused. Average values deal with integrations. This one deal with this one's deal with integrations. Integrations. So now I'm gonna put also something in the front. It's gonna be b minus a. So now here's the thing. You have to understand what is this mean. Instead of just calculation is very, very easy. You just do integrate of that function and divide it by the boundaries. It's like super easy to understand. But the theory behind it is kind of important. So I didn't know this. I'm going to show you something at 4th grade that you don't know something at 4th grade.
True. I was stupid in 4th grade. I still am.
Okay, remember in 4th grade you see the division sign, right?
Yeah.
And do you know what does the division sign symbolize?
Oh, it's like
It's a fraction.
How?
So let's just say if I have 12 divided by 3 like this, right? What do you think?
12 over 3, or the ratio. 3 divided by 12, 3 over 12.
It's a rate of change.
It's the integral of 12.
What is 3 over 12?
I forgot that.
Yeah, you gotta put it in Jeopardy.
12 divided by 3.
He doesn't understand non-Jeopardy.
I don't know how this works.
What is the division symbol?
Yeah.
It's so you can like do long division.
Wait, actually?
It's a square. It's half of a square. A rectangle.
Oh.
It's half of a rectangle.
It's
a
12 to the 1/2 power.
What?
I don't know. But that's half of a
How is the
square.
square root
It's
of
a
12?
third of
Oh,
a
wait.
rectangle with the area of 12.
It's square root 12 times 3.
What?
Right?
Oh, it's the square root of 16.
Okay.
Mr. Yang is stupid.
Okay.
It's 1 over
So
I never wrote it.
okay.
like
So 12 represents area of this rectangle.
That's what I said.
Then
No, I straight up did. I said 12 was the, you cut the rectangle into 3 parts.
Oh my god.
okay. So if you have the length or the width is 3, what is the
4.
length?
Because 3 times 4 equals 12.
Yes,
That's
or
what I
12 divided by 4 is equal to 3. So I know what you're trying to say, but it didn't mention that it's actually one is the width, one's the length. So those are things that it's kind of important. Now, remember yesterday we also talked about trapezoid, right? We make it a trapezoid into rectangle, right? Does that make sense? We make it a trapezoid into rectangle. So what happened is, what does this mean to you? What is 1 over b minus a of integration between a to b of f of x dx? What does that mean to you?
The b minus a is the volume, and it's got a width of line.
Yes?
Wait.
Area.
One person.
So it's the area under a function from point A to point B.
Over
No.
B minus A.
But you're on the right track, yes.
I don't know what you said. I don't really know if it's like
She's not paying
what I'm
attention.
saying.
Shh, go ahead.
I don't know if it's what I'm saying because it's like the inside is the area, and then if you divide it by b minus a, that's like the length. So then when you divide it, you get like the other side.
Okay, so you're on the right track. Yeah, you're right. So I'm gonna draw it to you to really shows that. So here's the function, and we're gonna name this function as function x, f of x. Now I'm gonna draw it like this in particular way, so that makes it easier for you to understand. So hold on, I'm gonna go up a little bit. Right, and this is like a perfect wave functions, and we have this.
That kind of looks like sine.
Yeah, it's a sine graph with a vertical shift of 3. So let's just say between here to here, let's just say between A to B, right? So this, the red part is going to be the area of this, right?
Yeah, it's gonna be 3 times b minus a.
So if I take this area, divided by the width, I will get a special value, and this value is going to be
Theta.
this height of this rectangle, that represents the blue area, represent exactly same as the red area,
Yeah, that makes
the
sense.
height.
That's what I said.
So what happened is, realistically, I can take this part, right, and I can shove it here, right?
Yeah.
So then you got become a rectangle. So if you understand that, that's a very, very crucial idea on AP exam. They really test that idea, and they've written the question in that way to make you think that you had to think it that way. So it's actually pretty interesting. So this is this average value. Okay, average value. Now for this class, you guys have to understand that you can also get this value C. That's called mean value theorem for integral. So so this is called mean value theorem for integral. And it's the exact same thing, mean value for integral. So that just means f of C times b, f of C times b minus a equal to integration of f of x dx a and b. Now this one is almost exactly same as the average value, because if you divide by both sides you get average value, right? But instead of mean value theorem for integral is kind of different. You are trying to find the value of C. You're trying to find the C. Once you find the C, that means at this C, you got that height of average value. So you can actually evaluate which x value that's going to give you average height. Do they always have one? No, they can have multiple. If I keep on oscillating, if I build another functions, right? If I just say, if I build a function that's just oscillating something that's say really fast. And then you can have multiple C's. You can actually multiple C. Then the work is the same thing. The work you can divide it by both by b minus a, right? You can do like this, and then you just use the function. For example, the function sine of x. You're gonna say sine of C is equal to that value, and you can solve for C once you get done. So you can get the x value represents the height of the function. Now that's mean value theorem for integral. They don't always test it, but I'm just going to tell you, I didn't have a chance to teach in other class on this, so you guys are usually a little bit faster, so I will teach this, but you don't always need it for mean value theorem for integral. You just need to know what is average value. Now don't get confused between those two, because they both are popular questions. A lot of people on the test, they tended to put one to the other. So make sure if they say value, it's integral. Rate of change is always derivative. You can do this to any function. If x squared between 0 to 2, then just going to be integration of x squared dx 1 over 2 in the front. And that's it. You don't have to do anything extra, but the idea, you have to understand the average height that represents that. Now mean value theorem for integral is to find out the x value, give you the height. Now what we're going to do next is something also super important. Now it's so important, the theorem is called fundamental theorem, and we already talked about this before. Fundamental theorem of calculus. Okay, so there's a part 1. We only did part 1. Part 1 says integration between a and b of f of x dx. If I integrate this, if I integrate a non-capital F, what am I going to get? Jake, are you back?
Yeah, I'm back.
Okay. Well, if we integrate a non-capital F, what am I going to get?
You're gonna get
The lowercase f.
yeah. It's gonna be the capital F. I don't know.
It's going to be the uppercase F, right?
Yeah.
And between b and a, right? So final result should get you f of b minus f of a. You do this with definite integral every single day that we're being past 3 weeks or 4 weeks. So we did that, but what is part 2, right? So fundamental.
It's gonna be the same thing.
Man, I love derivatives.
I hate derivatives.
Now part 2 is it's harder for people to grasp because I'm gonna give you a very awful analogy, which is just think about hammer and nail. How many of you guys use hammer and nail before?
Yeah, I'm cool.
Never, ever? Never?
Of course, AJ has it.
Okay, good.
Christ.
AJ, you know how to use hammer?
Yes.
Are you sure?
Yeah, you just pay work.
I've actually seen. I'm pretty sure I've seen him use a hammer and nail.
Just pay those guys.
We had to build a whole set.
Yeah. But I did it more because I was better at using a hammer.
I just thought this generation is a bunch of softy, like snowflake. Is that what you guys called
I
it?
was born on a farm in Ohio. No, that's
Oh.
what we call
Yeah,
the
sure
libtards.
Mr. Yeah, I'm just different. I just like.
Wait, I mean, I ask you, if I call somebody snowflake, is that a bad term?
It's kind
Just
of.
that they're sensitive, like, to everything.
I
You guys need
wouldn't
to
say
fire
it.
Dylan, man.
It's just. Yeah.
We're wearing clown costumes.
It does. It's not like bad.
It's not bad, right? Okay. So yeah, so I thought this generation is like snowflake generation.
I saw that.
So what happened is, you know, if you are a perfect handyman, like if you nailed it in, there's the other side of the hammer, you can actually take the nail out, right? Using leverage to take it out. But when you take out, normally it's not straight. Unless you are very, very professional. You hammer in the right way and you take out the right way, you still use the same nail. That is one out of few chances, right, that able to do that. Because most of the time, it's going to come out crooked. Does that make sense?
Yes.
Okay. So what happened is this. We have a fundamental theorem of calculus part 2. That just told you that you can integrate something and then take a derivative right afterwards. So which two things you hate. So
That's pointless. Why would you do that?
Yeah, I was gonna say, doesn't that just bring you back?
You have the plus
watch
C. You have the plus
watch
C.
the magic. Okay, watch the magic.
So,
At first, you probably see that's a pointless. And you're going to say, if you pull it out, it's going to be a nail. If I integrate a function, if I take a derivative function, it's going to go back to the function.
kind of bend that
Which is that's exactly what function in fundamental theorem calculus part 2 says. If I have a, and now between this is x. Now, be careful. Shh. AJ, shh. Don't talk.
He's talking to me.
Oh, no. Andrew. Sorry.
You're just confused all the time.
Andrew Green. So if this is a variable, then you have to be very cautious. The boundary is a variable is something we never seen before. Now, not only that, we're going to take a derivative before the integration. But integration is going to happen first. Now, if I integrate something like, say, f of x, well, just like something before dx. Now, I'm going to go back, I'm going to get f of x. But, however, the story is a little bit more than that. The story is more than that. This is the fundamental theorem of calculus. This only happened in a perfect situation. The problem is, the thing is not always perfect. Things can actually work out pretty interesting.
Nobody's perfect, Mr. Yeah.
Nobody. Unless you are Will Robinson. So, if you have a of x, right? And then I'm just going to do the integration first. I'm just going to do integration. I'm going to show you what actually happened. Even though you might not think it's important, it's very, very important. So I'm not going to take a derivative of this yet. I'm going to say d to the dx. I'm going to just integrate this f of x here. So I'm going to write down in blue. This one's going to be f of x. Now what happened is going to be a red still in the front, d to the dx. And now integration of this is going to be big F of x minus big F of 0. Does that make sense? Now after that, I'm going to take a derivative of this. If I derivative this, it's going to be from capital F to non-capital F.
Wait, I have a question. Why is it big enough for 0?
Yeah, why?
It's A, sorry.
Yeah.
Okay.
Good question. So this one's gonna be f of x. Now I'm gonna do derivative, but when we do derivative, there's always a chain rule. Even though it's simple as f of x, there is a chain rule. Why the chain rule matter? Because that is gonna be times 1. Now, do they always 1? No, because the boundary can change. And that's what we talk about. It's not always a perfect situation. Now, I have a minus sign of f of 0 times derivative of 0 is going to be 0. So luckily, this go away and you go back to f of x. And this is what actually happened. Yes?
Why is it 0 again?
Because derivative of 0 is still 0. Think about y equal to 0 is a horizontal line on x-axis, right? What is the slope of that line is still 0.
Any like basic numbers.
Well, why did you just put like f of 0?
Because I take a derivative of the big F is non-capital F of 0, of A, sorry, it's A. You're right, it's A. So derivative of A is going to be 0. So that's going to give you a 0. So that is a good question. And I was making a mistake. Good job.
Keep saying 0.
They kept putting f of
I don't know why I keep on putting 0. Okay, so if that's true, right? Now, we're going to give you a situation where it's not perfect. Okay? And we also going to give you a situation that you don't know how to take an integral of. So we're going to give you a situation that says this integration between x squared to 0.
Oh my goodness.
And then we're going to give you an ugly function. It's called natural log
No.
of t dt. Okay, t doesn't matter. If it's x, it doesn't matter. But right now, you don't know how to take an integration of natural log of t. But that's okay, because, and there was d to the dx in the front. Now, the problem is, I cannot take an integration. Luca, seriously? That was nice.
Look at this.
Like Among Us.
Yeah.
Okay, so the problem is I don't know how to take integration this function. Now, here's the problem. Because I don't know how to take integration of this function, I can't really do this part, right?
True.
So that's the first problem occur. So what we're going to do, like what we're doing, we're going to assume something. We're going to assume the f of t is equal to natural log of t. And I don't have to know if I know how to take a derivative of this function or integration of this function. I just need to know what is integration of f of x. That's what's the nice thing about f of x, because since we're doing integration, we're doing derivative, it's still going to go back to nail. The nail is going to be bent this time as opposed to before. Sometimes it can be bent very badly, and sometimes very, very nicely. So we're assuming this. So what I'm going to write? I'm going to write down x0, x to the 2, x squared to the 0, d to the dx. Now I'm going to say f of t dt. Now what's nice if I integrate this, now I can integrate it. Unlike before, I don't know how to integrate natural log of x or natural log of t. If I integrate this, it just becomes what?
Yes.
What does it become?
Oh, f of x squared.
It's a non-capital F or capital F? Capital F of x squared minus f of 0. Now I'm going to take a derivative of this function. So that's going to be f of x squared. Now times the chain rule, which is normally people forget, is this 2x because of chain rule.
Oh.
It's because
And the minus f of 0 times 0.
that's gonna.
Because that's just going to be completely go away, and that's okay. So now we got a f of x, x squared times 2x. Now we say this is equal to this. Therefore, I just need to plug in x squared. So it'll be natural log of x squared times 2x. So that is an equation we didn't know how to take integrate. We don't know how to integrate. But we integrate it as is. But we take a derivative after. But what happens when you take a derivative after? There's a chain rule involved. the chain rule affecting this function. Remember, normally if this is x, it will go back to what? Natural log of x, original function. So we don't have to do math. It's a nail. If you put it in and pull straight out, still same nail as before.
Wait, what happens to the dt in this equation? What, like,
It's the decomposer.
Well, in order to integration of natural log of t, you don't have to have a dt in order to do that. So we just convert that
I thought that
to
was another variable.
no.
Oh, yes, sir. Anything for my big Willie. Mister, I'm gonna ask my parents if they can pick up my sister instead so I can come here because I do need help with homework anyways.
Cocoa Puffs.
One go, one go.
Yeah, might come in. Let's see.
I'm gonna lock the door.
Lesson number 2. You ready?
Lock the door.
You want me back.
I don't want you.